April 1942. Before sunrise, the West Coast shipyards were already alive with the metallic pulse of a nation rushing against time. Floodlights carved long white scars across the hulls of half-finished vessels, and the air trembled with the rhythm of riveting guns. Thousands of American workers, men and women, veterans of factories, farms, and unemployment lines, moved through the fog like the cast of an industrial epic no one had rehearsed, yet everyone seemed born to perform. They were building a ship that wasn't meant to be beautiful. It was meant to survive. The Liberty ship was a block of steel on a timer, 441 feet of welded urgency, a merchant vessel conceived not for elegance but for endurance, designed inside offices in Washington and drafted on the backs of envelopes by engineers who understood the single truth shaping the war in 1942. The Atlantic was bleeding tonnage faster than the Allies could replace it. German U-boats prowled in wolf packs, sinking American and British cargo ships faster than American shipyards could produce them. The math was brutal, and the math was winning. But the United States was about to rewrite that equation. On the morning the SS Robert E. Peary began construction, almost no one believed the rumors. 4 days. 4 days to take steel plates, pipes, engines, screws, beams, and boilers, and turn them into a ship capable of crossing an ocean? It sounded like a publicity stunt, something designed for newspapers, not seawater. Yet the challenge had already spread through the shipyard like a spark thrown onto dry timber. Workers sharpened tools, cleared tracks, rehearsed sequences. Every foreman, every welder, every crane operator knew that if they succeeded, they would be proving something beyond engineering. They would be proving that the United States could outbuild a war. The shipyard supervisors had broken the project into hundreds of microtasks, choreographed like a military operation. Prefabrication was the secret weapon, sections constructed in parallel, then moved into place like colossal steel puzzle pieces. Nothing about the Liberty ship was revolutionary individually. It was the tempo that was unprecedented. America wasn't inventing a new vessel. It was inventing a new way of building. As sparks cascaded from scaffolds and the hull began to take shape faster than anyone expected, a strange tension settled over the yard. This was no longer just about steel. It was a race, against German torpedoes, against the Atlantic winter, against the fear that the world might collapse under the weight of lost convoys. Every hour saved meant cargo delivered. Every ship launched meant Britain would eat, armies would move, fuel would burn where it was needed most. And somewhere within that frantic construction, under the cranes, above the dry dock, across the lines of welders whose masks glowed like blue ghosts, something larger was being forged. A new identity for American industry. A promise that the country's strength was not only its soldiers, but its workers. A belief that speed itself could become a strategic weapon. On the 4th day, the Peary would slide into the water. But on the first day, this day, the story truly began. By early 1942, the United States faced a crisis that no amount of optimism could soften. The Battle of the Atlantic had reached a mathematical breaking point. German U-boats, faster, coordinated, and operating with refined tactics, were sinking Allied merchant tonnage at a rate the U.S. Navy could not counter and American shipyards could not replace. Entire convoys disappeared beneath the waves. Oil tankers burned on the horizon like floating pyres. Grain, fuel, machinery, aircraft parts, and ammunition, the bloodstream of Allied survival, were vanishing into the deep. Inside the Navy's Bureau of Ships, the numbers were brutally clear. If the United States did not flood the ocean with new hulls, the Atlantic would collapse. The Liberty ship was not born from dreams of innovation, but from the raw demands of arithmetic. The design was based on a British emergency cargo ship, simplified further by American engineers who understood the stakes. Instead of riveted construction, the traditional, meticulous method requiring master craftsmen, the Liberty ship used welding. Welding was faster, cheaper, and required less specialized labor. A ship built with welds didn't need decades of shipbuilding tradition. It needed training, discipline, and organization. That made the Liberty ship more than a vessel. It made it a strategy. Across the country, the Maritime Commission pushed for a new doctrine, industrial simultaneity. Instead of building a ship from keel to deck in sequence, Every section would be prefabricated in parallel. Bow sections, midship blocks, deckhouses, engine rooms, all produced like oversized components in a vast assembly line. America wasn't merely adopting mass production. It was scaling it to a degree the world had never witnessed. But efficiency alone wasn't enough. The United States needed people, millions of them. Men who had never worked a shipyard. Women who had never been allowed near one. Migrants, farmers, teachers, machinists, veterans of the Great Depression. In 1942, the shipyards became a new kind of front line, defined not by uniforms but by steel-toed boots and lunch pails. In Richmond, California, where the SS Robert E. Peary would be assembled, Henry Kaiser had transformed a modest coastal facility into the greatest shipbuilding complex on Earth. He introduced rotating shifts, mobile equipment, standardized workstations, and medical care for workers, an unheard-of innovation at the time. Kaiser believed something radical, that speed was not a compromise to quality, but a path to mastery. And he intended to prove it on a scale that felt almost mythic. Every decision surrounding the Liberty ship served one purpose: create a cargo vessel robust enough to cross the Atlantic, cheap enough to replace in quantity, and simple enough to build faster than U-boats could destroy. The stakes were not abstract. Britain's fuel reserves dipped to dangerous lows. Soviet supply through the Arctic convoys faced annihilation. American troops preparing for operations overseas needed vehicles, rations, everything that moved a modern army. All of it required ships, anonymous, unglamorous cargo carriers whose importance exceeded that of many warships. By the spring of 1942, the United States had two choices: build faster than at any time in human history, or watch the war tilt beyond recovery. The Liberty ship program was the answer, and the Peary would become its symbol. By mid-1942, the situation in the Atlantic reached a threshold that military planners had feared since the opening months of the war. A logistical collapse was no longer theoretical, it was approaching measurable reality. German Admiral Karl Donitz had perfected the Wolfpack strategy, coordinating multiple U-boats to attack convoys at night, often overwhelming escort vessels with sheer volume. Allied intelligence struggled to keep pace, and American naval air coverage remained stretched thin across thousands of miles of open ocean. For every ship built, two seemed to vanish. For every convoy that arrived, another limped into port half destroyed. The crisis intensified when U-boats began operating close to the American East Coast, exploiting gaps in patrol coverage. Known as the Second Happy Time among German submariners, this 6-month period saw tankers torched within sight of coastal cities. Flames from burning oil ships reflected on the windows of beachfront hotels. The war was no longer distant, it was at America's doorstep. Washington understood the implication. The United States could not simply defend the Atlantic, it had to overwhelm it. This reality turned shipyards like the Kaiser complex into strategic assets on par with naval bases and airfields. Construction speed became a weapon, and every wasted hour a liability. Building a Liberty ship in 220 days, the pre-war standard, was useless. Even 40 days, the early Kaiser benchmark, was no longer enough. The U-boats were not slowing down, so the United States had to accelerate. Planners began tracking production the same way commanders tracked divisions and fleets. Raw steel allocation became a battlefield. Supply chains spanning thousands of miles were re-engineered to ensure that no shipyard stood idle waiting for plates, beams, or pipe sections. Rail cars were prioritized for ship components, and coastal states saw entire new industries emerge overnight. Flame-cutting yards, paint factories, and welding supply depots feeding an industrial organism that seemed to expand by the week. And even this wasn't sufficient. The Peary project, conceived inside Kaiser's offices, was a provocative challenge to the entire system. If America could build a ship in just 4 days, it meant the United States could control the rhythm of the Atlantic. Not by superior warships, but by pure volume. If the Germans sank 10 ships, America would build 15. If U-boats claimed a convoy, another would be ready before the next moon cycle. It was warfare by production, a concept more radical than any new weapon at the time. Workers felt the urgency in every shift. Schedules tightened. Prefabrication crews rehearsed moves with near-military precision. Cranes were synchronized like artillery batteries. Welding teams practiced layouts on wooden mock-ups to minimize errors during the real build, shaving minutes from operations that once took hours. The Peary wasn't simply a publicity stunt. It was a message, to Berlin, to London, and to every American watching the war unfold. A demonstration that the United States could bend time itself through industrial willpower. That 4 days could be enough to change the Atlantic's arithmetic. Every day closer to the Peary's launch meant 1 day further from Allied defeat. And the countdown had begun. Inside the Richmond shipyards, the plan to build the SS Robert E. Peary in 4 days began as a whisper, a dare exchanged between foremen who had grown accustomed to breaking records. By the summer of 1942, Henry Kaiser's yards were already constructing Liberty ships in astonishing times. 12 days, then 10, then 7. Each new benchmark felt like an act of defiance against the Atlantic War. But the idea of 4 days was different. It felt impossible, a number that belonged in a headline, not a production schedule. Yet impossibility had never stopped Kaiser. In a glass-walled planning room overlooking the dry dock, senior engineers gathered with stacks of blueprints, stopwatch logs, and diagrams of prefabricated sections. The challenge was not simply reducing the build time, it was rethinking what time meant in shipbuilding. Traditionally, construction followed a linear path. Keel laid, frames installed, hull plated, deckhouses added, engines lowered. The Peary team would break this sequence apart. Everything that could be built before the keel was laid would be built. Everything that could be welded before the hull took shape would be welded. The result was a choreography more akin to staging a battle than building a ship. 50 major sections were drafted, standardized, and assigned to specialized crews. Welders worked in pods. Pipefitters were reorganized into strike teams that moved like mobile units. Electricians rehearsed cable runs on test frames. Even the riveters, though most of the ship was welded, were drilled for the few traditional tasks that remained. Every second was counted. Every mistake had consequences. A misaligned plate wasn't just an error, it was a delay in a record that had no room for delays. Kaiser's supervisors walked the yard carrying clipboards marked not with days, but with hours. A crane movement scheduled for 9:15 couldn't occur at 9:16. A hull section meant to arrive at sunset couldn't arrive after dark. The entire shipyard, tens of thousands of workers, had to function like a single machine. But the workers themselves were the key. Americans from every corner of the country had come to Richmond seeking wages, purpose, or simply a place in a war that demanded all hands. Many had never touched steel before. Yet under the pressure of production, they became experts at a speed that defied common sense. Women welded at rates that stunned inspectors. Migrant workers mastered cutting torches in weeks. Veterans of the Dust Bowl learned precision tasks that required millimeter accuracy. They weren't just building a ship. They were building a reputation, for themselves, for their country, and for the belief that industrial democracy could outpace fascist militarism. When the plan for the 4-day build was posted on the yard bulletin boards, the reaction was electric. Some laughed. Some shook their heads. But most stared at the schedule as if it were a battle map. The Peary wasn't a ship anymore. It was a challenge, a test of American resolve materialized in steel. Preparations intensified. Prefabrication yards were stocked with components delivered by trains that ran without interruption. Night shift crews were doubled. Spare equipment was staged near every critical station. Engineers ran simulations late into the night, testing crane clearances, weld sequences, and manpower distribution. And then, a date was chosen. November 1942. In 4 days, a Liberty ship would rise from nothing. And if the plan held, it would sail into history. The night before construction began on the SS Robert E. Peary, the Richmond shipyards looked less like a workplace and more like a fortified industrial camp preparing for a decisive operation. Floodlights cast long beams across stacked steel plates and half-assembled prefabricated modules. The dry dock itself, empty, silent, waiting, resembled a battlefield before dawn, defined not by smoke or ruin but by anticipation. Inside the planning offices, the final coordination meeting stretched past midnight. Engineers reviewed every sequence, tracing the path of each crane, each welding team, each transport dolly. Color-coded charts covered the walls, marking the exact minute a hull section should leave the prefabrication yard, the precise rotation of the gantry crane as it swung overhead, and the sequence of welds that would tie the entire structure together. Nothing was left to chance. The Peary build was no longer a challenge, it was an engineering campaign. At the heart of the plan lay the concept of parallelism, the idea that dozens of operations could occur simultaneously without interference. The Liberty ship's design made this possible: flat surfaces, large modular sections, and a hull form that welcomed uniformity. But on the Peary, parallelism would be pushed to extremes. While forward hull plates were welded, deck beams would be lowered. While bulkheads were aligned, machinery foundations would be installed. Every task that could begin early would. This required materials, mountains of them. Rail cars had been arriving for days, delivering steel plates pre-cut to exact measurements, boilers already fitted with insulation, engines pre-tested for alignment, and wiring looms organized into bundles marked for specific compartments. Suppliers across the West Coast had synchronized their production schedules to meet the obligation. For one ship to be built in 4 days, dozens of factories had to operate with military timing. The workers knew it too. Many arrived early for their shifts, driven by something that felt larger than a paycheck. Welding crews oiled their torches. Crane operators ran last-minute checks on cables and brakes. Supervisors walked the aisles with the intensity of officers inspecting troops. Even the cafeteria extended its hours, ensuring that no worker, on day shift or night shift, would slow down for lack of food. A sense of unity settled over the yard. Not patriotic fervor, something quieter, more grounded. A collective determination that this improbable feat was within reach. And yet, beneath the confidence, tension simmered. Everyone understood that a single mistake could cascade through the schedule. A misaligned bulkhead could throw off the crane timeline. A faulty weld could force a rework that the 4-day clock simply could not allow. The Peary's construction wasn't a sprint, it was a precise rhythm, and the entire shipyard had to keep tempo. In a corner of the yard, a group of welders stood watching the dry dock. They didn't speak much. They didn't need to. Their masks would ignite the first sparks that would turn empty air into the beginnings of a hull. For them, the challenge was personal. To build a ship in 4 days was to prove that ordinary Americans, workers, immigrants, women, day laborers, could achieve what the world deemed impossible. When the final whistle blew shortly before dawn, the shipyard fell into a tense calm. Tools were lined up. Sections waited on flat cars. Cranes stood poised like giant steel sentinels. In just a few hours, the operation would begin. 4 days. A ship. And an industrial miracle the world had never seen. The first day of the SS Robert E. Peary's construction began in a blast of sound, the sharp whistle echoing across the Richmond shipyards like the opening gun of a race. Workers surged toward the dry dock, and within seconds, the stillness of the early morning was replaced by a storm of metallic rhythm. Sparks burst from torches. Cranes growled into motion. The Peary did not begin as a keel in the traditional sense, it began as an interlocking choreography, a hull emerging from multiple directions at once. Prefabricated sections rolled toward the dock on flat cars in an unbroken procession. Each module had been measured and trimmed until the tolerances matched the pacing of the cranes that now hovered overhead. The first major hull sections, giant steel blocks weighing dozens of tons, swung through the air with a precision that defied their size. To the welders waiting at the dock's edge, they looked like buildings suspended on cables. As the modules descended, alignment teams met them with hydraulic jacks, wedges, and measuring tapes. They moved fast, checking the placement of every flange and plate before giving the signal to weld. The moment the first spark hit steel, the Peary existed. Not in spirit, not in plans, but in reality, a welded seam connecting the earliest parts of her hull, a line of heat that marked the beginning of the 4-day countdown. The atmosphere inside the dry dock felt electric. Welders worked shoulder to shoulder, pouring molten lines into seams that were still warm from the last torch. Supervisors directed traffic with clipped gestures, making sure no crane swung too close to another. Overhead, the gantry crane operators executed a delicate ballet, moving their loads in arcs that had been rehearsed for weeks. The hum of machinery blended with the beat of hammers and the hiss of welding rods, creating a single unified sound, the voice of the shipyard at full power. Every hour brought new challenges. A midship plate arrived slightly out of spec, forcing rapid grinding to correct the fit. A crane's brake hesitated on a descent and had to be adjusted without losing precious minutes. A sudden gust of cold Pacific wind pushed a suspended module off angle, requiring the rigging team to steady the load by brute force. None of these setbacks could be allowed to multiply. Every task was interlinked, and delays threatened to ripple through the entire 4-day build. But the crews adapted with a speed that astonished even the foreman. Many had worked together long enough to anticipate each other's moves. They passed tools without speaking, adjusted supports before instructions were given, and closed welding seams so quickly that the inspectors could scarcely keep up. As the morning turned to afternoon, the hull began to take on recognizable form. The bow section rose first, a steel curve pointing toward the cranes like a promise. The midship blocks followed, settling into place with a thunderous echo that rattled the scaffolding. By sunset, the stern module, with its massive rudder post already in position, hovered over the dry dock like a giant dark shadow before easing into its final alignment. By the end of day 1, the Peary had achieved what normally required weeks. The skeleton of the ship stood upright, not yet whole, but undeniable. The workers paused only briefly, gazing at what they had created in a single day. It wasn't triumph they felt. It was momentum. A sense that the impossible was now in motion and could not be stopped. Day 2 began under a haze of exhaust and morning fog, the kind that clings to steel and makes every surface glisten as if the shipyard itself were sweating. The SS Robert E. Peary was no longer just a rising hull. She was an open structure waiting to receive the machinery that would give her purpose. If Day 1 was about forming the body, Day 2 was about installing the heart, engines, boilers, piping networks, and the labyrinth of systems that allowed a Liberty ship to endure the Atlantic. The first major task was lowering the triple expansion steam engine into the machinery space. It arrived suspended beneath the gantry crane like a colossal iron organ, the product of American foundries working around the clock. The engine was already pre-tested, its shafts balanced and pistons measured to tolerances unthinkable just a decade earlier. What made this moment remarkable wasn't the machinery itself, but the speed. Traditionally, an engine installation marked a milestone weeks into construction. Here, it was happening just 24 hours after the first weld. Rigging teams stood ready with guidelines, shouting commands as the engine began its descent. The machinery space was still surrounded by scaffolding, and the crane operator had only inches of clearance on either side. Every worker froze as the engine slid into place, resting on its foundations with a metallic thud that echoed through the dock like a heartbeat. Within minutes, crews moved in to secure bolts, check alignment, and begin connecting the first lengths of steam piping. Parallel to the engine installation, boiler crews were at work. The Peary's boilers, already insulated and pressure-tested, arrived on mobile dollies. They were positioned using a combination of brute manpower and mechanical jacks, slid into place with ropes, rollers, and precision that defied the rough environment. Electricians followed closely behind, threading cable through the thin corridors between bulkheads, unspooling wiring looms marked for lighting, communications, and control panels. Above the machinery spaces, deck sections continued to close in. Prefabricated units, some weighing nearly 30 tons, were swung into position like pieces of a giant steel puzzle. Welders sealed seams even as pipefitters crawled through partially enclosed voids below them. The shipyard was operating in layers, structure above, machinery mid-level, and piping and wiring below, a vertical dance that required constant coordination. The tension point of the day came shortly after noon. A key bulkhead section arrived with bolt holes misaligned by nearly an inch, an error that could delay the next crane lift by hours. Instead of halting work, the foreman ordered an immediate correction. Grinding teams attacked the edges of the plate, while welders reinforced the opposite side to maintain structural integrity. Within 40 minutes, The section was corrected, aligned, and locked into place. It was a small miracle inside a larger one. As daylight faded, the interior of the Peary glowed with work lamps. Shadows of moving figures danced across unfinished bulkheads. The hollow shell of the previous day now hummed with activity, pumps being tested, ventilation ducts being aligned, temporary power lines snaking through corridors to feed welding machines. By the end of day 2, the Peary had transitioned from a steel shape into a functioning organism. Her engine rested on its mounts. Her boilers were in place. Her main deck was closing in overhead. The ship no longer looked impossible. It looked inevitable. Day 1 had proven the workers could build fast. Day 2 proved they could build right. Day 3 opened with a different kind of urgency, not the frantic pace of raw assembly, but the meticulous discipline of refinement. The SS Robert E. Peary now stood unmistakably as a ship, her hull enclosed, her decks mostly in place, her engine secured deep within her core. But to survive the Atlantic, she needed more than steel and machinery. She needed identity, a bridge, a voice, a network of systems that allowed a crew to navigate storms, evade U-boats, and deliver cargo to ports thousands of miles away. At sunrise, the bridge module arrived in the dry dock. Prefabricated like all other sections, it hovered beneath the crane with an imposing presence, a rectangular tower of steel and glass frames, fitted inside with partially completed consoles, wiring channels, and reinforced platforms for navigation instruments. It was one of the most symbolically important lifts of the entire build. When the bridge went on, the ship gained its face. Workers gathered along the dock to watch the lift. Slowly, the crane raised the module, its cables taut, the structure rising against the pale sky. Foremen barked instructions as riggers guided the enormous block into alignment above the midship deck. The moment it touched down, applause scattered across the yard. The Peary no longer resembled a shell. She looked ready to command the sea. Meanwhile, deep inside the vessel, electricians worked with relentless focus. Navigation lights, engine telegraphs, emergency circuits, and compartment sensors all needed to be wired and tested. Cable trays filled rapidly with bundles of colored wires. Junction boxes opened and closed like mechanical lungs as teams verified continuity and load capacity. Every system was redundant. Every circuit had purpose. In a war where minutes meant life or death, reliability was as valuable as armor. On the deck below, pipe fitters snaked through narrow passages connecting steam lines, fuel lines, freshwater circuits, and bilge systems. Steam rose in thin clouds as pressure tests began, hissing softly inside the metallic echo of the hull. Where leaks appeared, welders descended immediately, sealing weaknesses before the next section could be tested. The coordination was staggering. Dozens of tasks occurring simultaneously in confined spaces, each dependent on the last. While the interior teams worked, exterior crews advanced the ship's signature silhouette. The mast sections were raised into position, each one a steel spine designed to support signal lights, radar reflectors, and antenna lines. Welders climbed the scaffolding like acrobats, sparks cascading in arcs that lit the tower shapes forming above the deck. Throughout the day, inspectors moved through the ship with clipboards and chalk. Structural beams were checked for alignment. Bulkhead seams were tapped with hammers, listening for hollow tones that indicated incomplete welds. Fire-resistant coatings were tested for adhesion. Ventilation louvers were opened and closed again to verify airflow. Even the ship's rudder underwent its first tests. Dockside engineers rotated the massive blade through a series of controlled movements, ensuring the hydraulic system responded with the precision demanded of a vessel meant to cross submarine-infested waters. As evening settled over the yard, lights glowed inside the Peary like stars inside a metallic constellation. The ship was no longer a skeletal project. She possessed definition, a bridge, a mast, machinery that breathed, systems that listened, and compartments that awaited crew. Day 1 had built the frame. Day 2 had given her power. Day 3 gave her intent, the ability to think, respond, and endure. The impossible deadline was now within reach. And Day 4 was coming. Day 4 began with a silence that felt almost ceremonial. Workers arrived before dawn, gathering around the SS Robert E. Peary as if standing before a monument still being carved. The ship towered over the dry dock, her silhouette complete, her systems alive, her steel warmed by 3 days of uninterrupted labor. This was the final stretch, the moment when loose ends had to become certainty and every unfinished task had to resolve into readiness. The first hours of the morning were consumed by inspections. Not casual walkthroughs, but rigorous, almost surgical examinations. Teams of naval engineers moved compartment by compartment, checking weld seams with flashlights and chalking each approved joint. Machinery crews verified alignment on the engine shaft, ensuring it connected true to the propeller line. Pipefitters pressurized the steam and water systems, watching gauges for fluctuations that signaled leaks I could see. At the bow, anchor crews tested the windlass, cycling the heavy chain links through its teeth. The anchor dropped a few feet, clattering against the steel deck, then rose again in a clean pull, the kind of simple motion that meant everything at sea. On the stern, the rudder shifted smoothly under hydraulic pressure, gliding from port to starboard with deliberate precision. These movements were not symbolic, they were the muscle tests of a ship preparing for war. Inside the Peary, the finishing work intensified. Carpenters fastened the last wooden panels inside crew quarters. Electricians mounted navigation lamps and sealed junction boxes. Ventilation teams secured ducts with quick welds and clamps. Painters followed behind, coating raw steel with the protective gray that defined Liberty ships, a color chosen not for beauty but durability in harsh salt air. Then came the lifeboats, swung over the rails and lowered into position, each one inspected for davit function, each rope checked for fray. Fire extinguishers were stowed. Emergency axes mounted. Watertight doors cycled open and shut as workers listened for the crisp metallic seal that meant everything aligned perfectly. As morning turned to afternoon, the Peary's deck grew crowded. Representatives from the Maritime Commission and shipyard leadership arrived, clipboards in hand. Their presence added weight to the already charged atmosphere. This was not just a launch, it was a proof of concept, a statement to the nation and to its enemies that American industry had crossed into new territory. One of the most delicate tasks of the day was the calibration of the ship's compass. A specialized crew climbed aboard with brass instruments and notebooks. They adjusted for magnetic interference caused by the vast expanse of steel surrounding the bridge. Their measurements were precise, their movements slow, as even the smallest deviation could render navigation unreliable in the open ocean. Only when they were satisfied did they record the final settings. Below decks, the engine room rumbled to life for the first time. The boilers were lit under supervision, pressure rising gradually as steam flowed into the pipes. Valves hissed. Gauges climbed. Engineers monitored every moment, ensuring that temperature and pressure stabilized within expected parameters. When the engine's pistons began their slow, rhythmic motion, a quiet cheer spread through the compartment. It was the first mechanical heartbeat of the Peary, alive after only 4 days of construction. By late afternoon, the scaffolding was removed. Workers unbolted temporary supports and cleared tools from the deck, leaving nothing but the completed vessel standing over the dock. Floodlights flickered on, bathing the ship in white brilliance. She looked finished, whole, impossible. And then came the final step before launch, the blessing of readiness, spoken not by officials but by the silent approval of the thousands who had built her. Welders stood with their arms crossed. Electricians rested on coils of cable. Crane operators leaned against railings. They looked at the Peary not with pride alone, but with a sense of disbelief transformed into certainty. In 4 days, America had made a ship. In 4 days, the workers had fulfilled a promise to the war, to the nation, and to one another. Now the Peary waited for water. The launch of the SS Robert E. Peary was scheduled for late afternoon, when the tide reached its optimal height. By then, thousands of workers had gathered along the edges of the dry dock and the surrounding walkways, forming a human amphitheater around the vessel they had brought into existence in just 4 days. The air buzzed with anticipation, but beneath it lay a quiet reverence, the kind reserved for moments that feel larger than the people witnessing them. The Peary stood poised at the edge of transformation. Over the last hours, yard crews had greased the launchway timbers with tallow and graphite, the age-old method that allowed steel giants to slide gracefully into the sea. Release blocks were checked twice, then a third time. Every shackle was inspected. Every timber was tapped to ensure no structural weakness lurked beneath the weight of thousands of tons of metal. The shipyard's loudspeakers crackled to life. A brief address was given, not with grand speeches or patriotic theatrics, but with steady words acknowledging the sheer discipline and effort that had made the moment possible. Everyone understood that this launch was more than symbolic. If the Peary entered the water cleanly, if she remained stable, if her systems responded after the impact, then the entire model of 4-day shipbuilding stood validated. As the ceremony ended, a hush fell over the crowd. Workers on the deck of the Peary moved into position. On the dock below, release crews prepared the trigger mechanism that would set the massive hull in motion. The shipyard whistle blew once, sharp, piercing, unmistakable. It was the call to readiness. Then came the second whistle, the release order. With a thunderous crack, the final restraining blocks gave way. For a moment, nothing happened. Then the Peary began to move, slowly at first, as if testing the idea of motion after 4 days of being locked in place. The hull shifted, inching forward as the greased timbers guided her descent. Workers held their breath. Supervisors shouted instructions. The crane operators, their machines idle, watched with hands gripping control levers out of instinct. And then she gained momentum. The ship gathered speed with startling smoothness, sliding along the slipway in a controlled, majestic rush. The hull's steel plates glowed faintly in the afternoon sun, reflecting the movement of the workers running alongside, cheering as the impossible unfolded before their eyes. The sound was unforgettable, a deep, resonant roar as steel met wood met water, and the ship transitioned from land to sea. When the Peary hit the water, a towering plume surged upward, drenching the launch crews in a spray of cold Pacific salt. The hull dipped, rolled slightly, then steadied, a perfect entry. Tugboats moved in immediately, securing lines and guiding the newborn vessel into deeper water. Inside the hull, gauges were monitored by inspectors who had boarded just before launch, checking for leaks, stress points, or structural shifts. None appeared. The vessel held true. From the shoreline, the workers erupted in applause. Not wild, celebratory applause, but long, sustained clapping that carried a weight of exhaustion and awe. They had built a ship in 4 days. Now, seeing her afloat, they knew the achievement was real. As the tugboats positioned the Peary for her maiden tests, the sun dipped low over Richmond, casting a golden light across the shipyard. The Peary's gray hull reflected the dying light, making her appear almost spectral, a ghost of industrial power drifting toward her first assignment. But she was no ghost. She was steel, sweat, and certainty embodied. Proof that the United States had found a new weapon, time itself. The Peary floated steady, engines silent but ready, awaiting the next phase, the tests that would determine whether the shipyard's miracle could survive the realities of war. The SS Robert E. Peary, now afloat and steady, faced the next challenge of the 4-day miracle, proving herself at sea. A shipyard launch was symbolic, but seaworthiness was uncompromising. A Liberty ship that could not handle open water, pressure loads, or mechanical stress would be as useless as scrap metal. The Maritime Commission knew it, the Navy knew it, and the workers who built her knew it most of all. The Peary had to perform, not in years, not in months, but in hours. On the morning after her launch, tugboats maneuvered the Peary out of the harbor. Fog rolled low over the bay, drifting across the deck and funnel like a pale shroud. Inside the bridge, inspectors and engineers gathered around the navigation console. The temporary crew, a composite team of shipyard veterans and Maritime Commission officers, stood ready to guide the ship through her trials. The first test was simple in concept, demanding in execution: propulsion. Down in the engine room, the boilers were brought to operating pressure. Steam surged through the pipes, warming the metallic belly of the vessel. Engineers monitored temperature gradients, noting how the rapidly assembled system responded to stress. When the order came, ahead 1/3, the engine engaged with a deep, measured thump. Pistons moved in precise rhythm. The propeller shaft began to rotate. On the deck, vibrations traveled through the steel like a pulse through bone. The Peary moved forward. Slowly at first, then with increasing confidence, the hull cut through the water. The wake spread behind her, clean and symmetrical, a sign that the hull's alignment, rushed though it was, held true. The inspectors exchanged glances. Admiration replaced skepticism in their expressions. Next came steering tests. In the wheelhouse, the helmsman turned the wheel to port. Below, the massive rudder shifted, pressing against the wake. The ship responded obediently, banking in a curve that technicians measured with stopwatches and angle charts. Starboard maneuvers followed, each motion smooth, steady, within acceptable tolerances. Then the Peary faced vibration tests, varying engine speeds, reversing thrust, rapid shifts in boiler pressure. Each cycle risked revealing flaws that could have been introduced during the accelerated build: warped plates, loose welds, misaligned bearings. But hour after hour, the ship held firm. Minor corrections were noted, but nothing severe. Nothing disqualifying. Out on the water, the hull creaked and flexed as all ships do. But it did so with the sound of a vessel built with purpose, not fragility. The most dramatic test of the day was the crash-stop maneuver. At full ahead, the order was given: full reverse. Inside the engine room, steam valves shifted, pistons slowed, then hammered in reverse. The ship's bow dipped slightly as momentum fought against counter-thrust. Waves surged along the sides of the hull. Inspectors gripped railings. The Peary shuddered, then slowed, then stopped. She had passed. By afternoon, the fog had lifted, revealing a coastline bathed in sharp autumn sunlight. The Peary completed turning circles, buoyancy checks, ballast recalibrations, and compartment flooding simulations. Technicians opened and closed watertight doors under pressure, checked bilge pumps, and verified anchor function. When the Peary finally returned to harbor, she did so not as an experiment, but as a certified ship. Workers lined the piers as she approached. They watched not the hull, nor the bridge, nor the deck fittings, but the wake behind her, straight, stable, confident. The impossible had crossed the water, and the Atlantic would soon feel the consequences. News of the SS Robert E. Peary's 4-day construction spread across the United States with a momentum almost as swift as the ship's own launch. Newspapers ran headlines that blended disbelief with national pride. Radio networks interrupted regular programming to report on the feat in Washington. Officials within the Maritime Commission and the Navy exchanged memoranda filled not with celebration, but with analysis, because the Peary was not simply a milestone. She was a signal. The United States had unlocked a new strategic dimension: industrial acceleration. Until then, the world believed that building a cargo ship required months. Craftsmanship, sequencing, and dockyard tradition set the pace. Even the early Liberty ship program, producing vessels in mere weeks, had been considered radical. But 4 days shattered every assumption. The Peary did not just challenge global expectations, she overturned them. Across the Atlantic, British officials responded with a mixture of astonishment and relief. Prime Minister Churchill, informed through a brief naval dispatch, noted that if such speed could be sustained, the U-boat war would shift decisively toward Allied favor. Britain depended on American tonnage for survival: food, fuel, ammunition, aircraft parts. Every ship meant another artery of supply, another guarantee that the island nation could endure. In Germany, the reaction was markedly different. Naval intelligence analysts reviewed photographs and reports with skepticism. A 4-day build was dismissed by some as propaganda. Others feared the implications. Admiral Donitz, commander of the U-boat arm, understood the mathematics more clearly than most. One Liberty ship carried roughly 10,000 tons of cargo. If the United States could produce them faster than U-boats could sink them, the German strategy would collapse. The Peary was not just a ship, she was a threat to the entire Atlantic campaign. Back in Richmond, however, the mood was quieter, almost introspective. The workers who had built the Peary gathered in small groups, listening to radio broadcasts, reading newspaper clippings pinned to bulletin boards, absorbing the growing national attention with a kind of restrained satisfaction. They knew what the outside world did not: the Peary's success was not a miracle of luck. It was the result of organization, planning, and the willingness of ordinary Americans to push their limits for something that transcended any single individual. The shipyard leadership, meanwhile, was already studying the build logs. Where had minutes been lost? Which crane had fallen behind schedule? Which tasks could be compressed further? For them, the Peary was not a final triumph, but a prototype, a proof that even more efficiency was possible. Other shipyards took notice as well. Across the West Coast, production targets were recalculated. Prefabrication yards expanded. Training programs intensified. Welders were assigned in larger teams. The Peary had established a new benchmark, and the rest of America's industrial machine was preparing to meet it. Beyond the practical impact, a deeper message began to take hold in the national psyche. The Peary's story spread through factories, farms, and small towns. Posters appeared showing Liberty ships under construction, urging workers to match Richmond's achievement. High schools taught lessons on wartime production. Recruitment offices used images of the Peary to encourage enlistment in industrial labor. The narrative was simple but powerful. America was not just fighting on distant fronts. America was fighting at home, with steel, with discipline, with speed. And in a war defined by attrition, by logistics, by the brutal arithmetic of supply, the Peary had demonstrated something extraordinary: that the United States could bend time to its will. The global reaction, whether hopeful or fearful, was unanimous in one aspect. The 4-day Liberty ship had changed the conversation. The question was no longer whether the Allies could replace their losses, but how quickly they could overwhelm them. The success of the SS Robert E. Peary did more than astonish the world. It ignited a transformation across the entire American industrial landscape. The 4-day build became a benchmark, a challenge, and a rallying cry for shipyards from the Great Lakes to the Gulf Coast. Suddenly, the question was no longer whether the United States could supply the Allied war effort. It was how overwhelming that supply could become. In Washington, analysts began calculating new projections. If one shipyard could reduce a build to 4 days, what could the nation achieve collectively? The Maritime Commission drafted revised output goals that bordered on audacious. Thousands of Liberty ships within a few years, tens of millions of tons of cargo capacity delivered faster than any maritime power in history had ever imagined. Across the country, the industrial infrastructure shifted to match these ambitions. Steel mills increased production by reorganizing shifts and introducing continuous casting methods. Foundries adopted new molding techniques that minimized waste and shortened cooling times. Factories that had once built locomotives or farm equipment now produced engines, boilers, and propellers at a staggering pace. The concept of prefabrication, once considered a novelty, became the backbone of American wartime assembly. Entire ship sections rolled out of inland plants on railcars before reaching the coast. Windows, doors, bulkheads, electrical panels, all standardized, all interchangeable. The Liberty ship's simplicity made this system possible. Its design was rugged, functional, and forgiving enough to allow components from different states, made by different hands, to fit together without compromise. Shipyards expanded rapidly. New ones appeared almost overnight, carved from empty stretches of coastline that only months earlier had been quiet marshland or undeveloped fields. Each yard replicated lessons learned from Richmond: modular workflow, parallel assembly, deep storage staging zones, and precise scheduling. Cranes increased in size and number. Welding schools grew in enrollment. Cafeterias fed thousands per hour. Housing complexes for workers, many of which became cities in their own right, rose beside the facilities they served. The ripple effect extended far beyond the shipyards. Railroads strained under the volume of raw steel, engines, and prefabricated blocks. Chemical plants produced unprecedented quantities of paint, insulation, and hydraulic fluid. Machine shops turned out gears, bearings, pumps, and valves in endless cycles. The American workforce, drawn from every region and background, became a single interconnected organism. The Peary had proven what could be achieved when all these parts moved in synchronized motion. Crucially, the psychological impact was just as powerful as the material one. The 4-day ship was tangible proof that American industry could outpace Axis production by sheer velocity. The Germans prided themselves on engineering excellence. The Japanese revered technical mastery. The United States, however, had discovered a new weapon: standardization at scale. Not the perfection of a single machine, but the disciplined repetition of thousands. This new doctrine spread to other wartime programs. Aircraft factories refined assembly lines. Tank plants reorganized to mimic shipyard workflows. Even ammunition depots adopted modular processes inspired by prefabrication principles. Across the nation, engineers spoke of the Peary effect, the shift from traditional craftsmanship to synchronized industrial power. And as these changes took hold, production numbers soared. Liberty ships moved down slipways in dozens, then hundreds. The United States built so many that storage fleets formed in quiet bays, ships waiting for cargo or deployment. By 1944, America was producing merchant tonnage faster than all Axis nations combined could destroy it. The Peary had shown the world that 4 days could build a ship. What followed proved something even more profound. 4 days could build a strategy. 4 days could build a doctrine. 4 days could build a war-winning machine. Behind the triumph of the SS Robert E. Peary and the explosive growth of American shipbuilding lay a quieter, more human story, one not measured in tons of steel or days on a construction chart. It lived in the exhaustion of shift workers, the calloused hands of welders, the echoing footsteps of night crews walking through fog, and the sacrifices of families who rarely saw each other except between overlapping shifts. If the Peary represented the industrial miracle of the United States, the workers represented its human cost. In Richmond, the workforce was a mosaic unlike anything American industry had seen before. Men from the Dust Bowl, machinists from the Midwest, longshoremen from the East Coast, migrants from the rural South, indigenous laborers from reservations, and newly trained women welders all worked side by side. The shipyard ignored many of the social boundaries that defined the outside world. Race, gender, and background mattered less than speed, precision, and endurance. The war had rewritten priorities. But the pace came with consequences. 4-day construction pushed the limits of physical stamina. Many workers lived in hastily built housing projects that struggled to keep up with the influx of families. Cafeterias operated day and night, yet lines still stretched into the yards during peak hours. Sleep became a negotiation with necessity. Short bursts between 12-hour shifts, interrupted by shipyard whistles, train horns, and the roar of welding arcs that never truly faded. Women, who now filled essential roles in welding, cutting, painting, and riveting, faced unique pressures. Many balanced grueling workdays with childcare, rationing lines, and the uncertainty of husbands, brothers, or sons sent overseas. They worked through fatigue, grief, and fear, shaping steel while waiting for letters that might never arrive. For many, the Peary became proof that they were not merely filling in for the men, they were redefining what American labor meant. Accidents, though minimized as much as possible, were inevitable in such an environment. Welding burns, crushed fingers, falls from scaffolding. The price paid in injuries was real and rarely publicized. The push for speed demanded vigilance. Supervisors patrolled catwalks with first aid kits. Nurses in on-site clinics treated cuts, smoke inhalation, and exhaustion. The workers pressed on, driven not by heroic speeches but by the stark knowledge that every Liberty ship delivered cargo that could save lives far across the ocean. And yet, despite hardship, a powerful camaraderie emerged. Workers shared tools, stories, cigarettes, and meals. Veterans of earlier builds taught novices without hesitation. Teams forged identities as strong as the ships they assembled. Welders who could close a seam blindfolded, crane operators who could place a module with inch-perfect accuracy, pipefitters who could read blueprints like poetry. These bonds carried them through the relentless pace. The Peary, with its 4-day schedule, amplified everything: pride, fatigue, pressure, triumph. When the whistle blew each morning, it felt less like a start to a workday and more like the continuation of a mission. The shipyard became a place where ordinary people, many of whom had never imagined themselves part of a war, realized they were indispensable. In private moments, Some workers wondered whether history would remember them, whether the headlines praising American industrial power would include the names of those who welded in the rain, who lifted steel with frozen hands, who traded comfort for contribution. The truth is simple. Without them, there would have been no miracle, no Peary, no four-day ship, no arsenal of democracy. The steel told one story. The people told another, quieter, harder, and every bit as vital. The four-day construction of the SS Robert E. Peary did not merely astonish observers or boost wartime morale, it rewired the technical foundations of American naval engineering. What happened in Richmond was not an isolated achievement, it was a revelation. A blueprint for a new era of shipbuilding, one in which the traditional hierarchy of design, materials, and process would shift under the pressure of necessity and innovation. Before the Liberty Ship program, naval engineering culture was defined by precision craftsmanship. Riveted hulls, step-by-step assembly, and master shipwright oversight were considered sacred. But the Peary demonstrated that speed could coexist with structural integrity when design favored modularity. The Liberty ship's simple hull geometry, straight decklines, and standardized components allowed engineers to break away from linear construction and adopt parallel build logic, a concept that became central to post-war shipbuilding worldwide. One of the most significant technical transformations brought on by the Peary was the normalization of welding over riveting. Welded seams were faster to produce, required less skilled labor, and avoided many of the long-term maintenance issues common in riveted ships. Early in the war, weld failures had raised concerns about brittle fractures in cold waters. But as techniques improved, inspectors and naval architects learned how to control metallurgy, preheating, and stress distribution. The Peary served as a proof point that welding could serve mass production at a tempo never before attempted. The precision achieved during the Peary's construction also pushed forward the development of standardized tolerances. For the first time, engine foundations, bulkheads, and structural plates from different factories, sometimes thousands of miles apart, were expected to align perfectly on arrival. This demand forced suppliers to adopt new quality control processes, better gauges, tighter machining, and more reliable material certifications. These improvements did not fade after the war. They became permanent features of American manufacturing. The concept of prefabrication also expanded dramatically. Engineers recognized that large modules could be assembled inland, shipped by rail, and attached to hulls with remarkable accuracy. This opened the door to distributed shipbuilding, an approach that continues to influence modern naval construction, where blocks of aircraft carriers, destroyers, and commercial vessels are built in separate locations and joined in massive dockside operations. Additionally, the Peary accelerated the adoption of critical path scheduling. The idea that thousands of interdependent tasks could be mapped, optimized, and executed with near-military timing became the cornerstone of large-scale engineering. Post-war civilian infrastructure, bridges, highways, refineries, all benefited from this discipline. The flowcharts used for the Peary's construction were primitive compared to modern project management software, but the principles were identical: sequence, timing, resource allocation, and risk mitigation. Even safety engineering evolved. The pressure for speed forced shipyards to rethink everything from scaffolding design to ventilation systems for welding fumes. These innovations laid the groundwork for standardized industrial safety codes adopted across American manufacturing in the post-war period. Perhaps the most enduring legacy of the Peary's technical success was its challenge to engineering orthodoxy. The four-day build proved that efficiency was not the enemy of quality, that proper planning, modular design, and coordinated labor could produce a vessel capable of crossing an ocean under threat of war. It forced naval architects to reconsider the relationship between design complexity and performance. In many ways, the Liberty ship became a lesson in humility. Sometimes the simplest design is the most effective, the most adaptable, and the most powerful when multiplied by the thousands. The Peary didn't just break records. It reshaped an entire field. A ship built in 4 days rewrote decades of naval engineering tradition and set a precedent that echoes through shipyards to this day. When the SS Robert E. Peary left the safety of the American coastline for her first operational voyage, she crossed an invisible threshold, from industrial triumph into the unforgiving reality of wartime navigation. The Atlantic in 1943 was still a battlefield, marked by shifting convoy routes, unpredictable weather, and the constant threat of U-boats that prowled beneath the waves like silent predators. A 4-day ship, no matter how extraordinary her construction, would face the same dangers as every vessel before her. Her departure from the west coast was modest, almost understated. There were no reporters on the pier, no speeches, no fanfare. The Peary slipped away with a skeleton merchant crew and a small Navy armed guard detachment to man the defensive guns, a necessity for Liberty ships passing through contested waters. These sailors had seen combat. They knew the stakes. Many regarded the Peary with a kind of cautious curiosity, fully aware of her reputation but unwilling to trust steel until it proved itself at sea. As she steamed southward toward the Panama Canal, the crew familiarized themselves with the ship's characteristics. They noted how her hull responded to swells, how her engine handled continuous operation, how quickly she settled into steady rhythm. Liberty ships were known for their stability, but also for their stiffness, a product of welded construction. The Peary was no exception. Her hull transmitted vibrations more distinctly than older riveted freighters, but her crews quickly learned her language. Each resonance, each pulse, each shift of the propeller told them something about her condition. Once through the canal and headed into the Caribbean, the Peary began to feel the weight of the war. Merchant vessels rarely sailed alone anymore. The risk of ambush was too great. The Peary joined a convoy, one of hundreds that crisscrossed the Atlantic, linking the factories of America with the embattled ports of Europe. Life aboard settled into the familiar rhythm of convoy duty. Constant lookouts, guarded lights at night, and the tension that came with every sonar ping or sudden change in course. At dawn on her 3rd day in convoy, the threat became real. A merchant ship 2 columns over erupted in a column of water and smoke, a torpedo strike. The convoy tightened formation. Escort destroyers raced toward the attack vector, dropping depth charges that shook the sea like distant thunder. The Peary held course, her crew bracing for the possibility of a second strike. U-boats often hunted in pairs or packs, and Liberty ships, slow and heavily laden, were prime targets. The Peary's crew listened to the distant detonations, each one sending a shiver through the hull. But the ship endured the tension with quiet resilience. Her engine kept steady. Her rudder responded crisply. Her structure, assembled in 4 days, showed no signs of strain. When the convoy eventually received the all-clear, the Peary continued as though nothing had happened, though every man aboard carried the memory of those minutes like a shadow. Crossing the open Atlantic tested her further. Winter storms rolled across the seas, lifting the Peary's bow high before dropping it into troughs that boomed against her hull. Waves crashed over her Ephesus, drenching the deck crew. The wind howled through her rigging. The ship flexed, groaned, endured. She was not elegant in the storm. Liberty ships rarely were, but she was solid, predictable, and steadfast. The crew learned to trust her not for grace, but for honesty. She told them exactly how she felt, and she never faltered. When the convoy finally neared the British Isles, the Peary bore the marks of a true Atlantic crossing. Salt stains on her rails, paint scoured from her bow, ropes swollen with water, and men whose faces showed exhaustion tempered by pride. She had done what she was built to do. She had carried her cargo, and she had survived. For the Peary, it was just one voyage among many she would make. For the workers who built her, it was proof that their 4 days of labor had produced not merely a symbol, but a ship capable of enduring the harshest theater of the war. The SS Robert E. Peary completed her first voyages without fanfare, blending into the vast armada of Liberty ships that threaded supply routes across the globe. She was not treated as an icon. She was not given special assignments. She carried cargo, sometimes ammunition, sometimes food, sometimes machinery, and she did so with the same unassuming reliability that defined the entire Liberty fleet. In war, anonymity was survival. And the Peary, the ship built in 4 days, embraced that anonymity with a kind of quiet dignity. Her wartime service was long and demanding. She crossed dangerous waters during the height of the U-boat threat, braved storms that battered the North Atlantic, and endured long convoys where tension hung permanently in the air. Crews changed, cargoes varied, ports shifted. But the Peary's character remained constant, steady under strain, predictable in weather, honest in her movements. She was not the fastest ship in a convoy, nor the most graceful, but she was among the most dependable. Like most Liberty ships, she lived a life measured not in decisive battles, but in the tonnage she delivered. And that, ultimately, was the measure that mattered. By the war's end, the Peary had survived what thousands of merchant sailors did not, a gauntlet of submarines, storms, and the brutal mathematics of logistics. When victory finally arrived, her work did not end immediately. She served through the transition years, helping carry the supplies that fed Europe, rebuilt shattered cities, and stabilized regions where famine threatened to follow war. Eventually, however, her usefulness faded. The world moved on, and newer ships, faster, larger, more specialized, replaced the rugged workhorses of the Liberty fleet. The Peary was retired quietly, without ceremony. She had entered history in a blaze of floodlights and applause, but she exited it the way most ships do, worn, weathered, and unremarked. And yet, her impact did not fade with her steel. The legacy of the Peary lived on in the shipyards she transformed, in the engineering doctrines she accelerated, in the production methods that reshaped American industry, in the post-war boom made possible by factories that had learned to build not just faster but smarter. Her influence rippled through commercial shipping, naval construction, infrastructure projects, and even the aerospace industry, where modular manufacturing became the backbone of rockets, aircraft, and satellites. But perhaps her greatest legacy was something less tangible. The proof that a nation's strength could be measured not only by the weapons it built, but by the will of its workers. The Peary showed that ordinary Americans, welders, pipefitters, carpenters, crane operators, electricians, could achieve the extraordinary when the stakes demanded it. She embodied the idea that speed, organization, and collective purpose could become strategic weapons. She demonstrated that ingenuity did not always require complexity, and that victory could be forged through discipline as much as innovation. In the decades that followed, historians, engineers, and naval architects looked back on the Peary not as a curiosity or a publicity stunt, but as a turning point, the moment when American industrial capacity crossed into a realm previously considered impossible. The ship built in 4 days became a symbol of what the nation could accomplish when urgency and unity aligned. The Peary did not change the war by herself, but she proved that the United States had found a way to outproduce fear, outpace destruction, and overwhelm the machinery of tyranny with sheer industrial will. In the quiet after war's end, her steel may have faded, but her lesson endures. 4 days can change history. 4 days can turn labor into legacy. 4 days can turn a nation into an arsenal.